Hello and welcome back to another festive coding session with Mr. Jacob. Today we will tackle the last installment of our Advent of Languages, where we did in the first 24 days of December the same thing in a different language each day. And today is day number 24. So happy Christmas. Today we will do something a little bit special. We will use a programming language to code ourselves a 3D model of our Christmas tree. Because what we did before in all of the 23 different days we had before is we implemented an output of this kind of ASCII art Christmas tree in a different language each day. And today, let me copy this Christmas tree out here because we will use it as kind of a reference. We will use OpenSCAD. And OpenSCAD is essentially kind of a programming language to describe 3D modeling, 3D models, and to, in the end, then generate those as a 3D model. And if everything goes to plan, I will, in the end, print this thing that we are generating here now with my 3D printer and show it to you at the end of the video. So please stay tuned for that. So let's first of all get our reference tree kind of in here, because that is more or less what we want to create. So yeah, that is the representation that we have. And I guess the easiest way to realize something like that is in OpenSCAD is to essentially kind of draw the 2D shape like we did before in other sessions with graphical based programming languages, and then rotate it around the z-axis to make a rotation shape. So I guess we start as always. We simply define our more or less functions. Functions in OpenSCAD are called module because they are modules of this three-dimensional thingy that we are going to create here. So we start with our module hello Xmas, and as you can see already, this kind of is like a normal programming languages with blocks and with functions or modules and stuff like that. And our hello Xmas module actually consists of different things. First of all, I think this hello Xmas module should call the shape or the contour of our hello Xmas or our Christmas tree there, and draw that first. And once we have that ready, we will rotate it. So essentially, we want to draw our let's call it maybe tree profile first. And we will then later on do the rotation and stuff. And let's essentially call our hello Xmas thingy here. And now let's define another module called tree profile. And as such, it can draw things. And for now, we are usually doing something like hello Xmas on the screen. We can't do that here. Let's quickly just print out a square, maybe with something like 100 by 100 in size. And let's render that. And as you can see here on the side, let me move this a little bit more into your spacing there. We have now drawn a flat square on our 2D axis here. And that is essentially how we will build up our tree. And then in the end, we will rotate it around the z-axis. So I guess let's going. How would we do that? We do that as we usually do. However, we are starting from the bottom, as our coordinate system starts here at the 0, 0 position in the middle there. So we are creating one half of our tree, and we are creating it from bottom to top and not from top to bottom as we did before. So I guess we start with the trunk of the tree. So maybe let's do that by calling something like tree trunk, and simply doing a module called tree trunk, or let's call it, maybe it should be trunk profile. I guess trunk profile would be the better naming, because we want to make sure that trunk profile, that we incorporate those idea that it is only the profile that is later on rotated. So we have this trunk profile. So how would we usually do that? Usually we do that by creating it in the size of 2 characters wide and 2 characters high. And I think I want the same dimensions for our Christmas tree because that makes reasoning about this a little bit easier. So let's maybe define something like maybe char width. I have no idea, like 10, for example. We are in the millimeter scale here. However, we can, of course, later on scale our tree like we want, and char height to have some sort of height and width there that we can actually work with. And the height usually in the terminal is kind of double the width. So let's do that. Char width times 2. So now we should be able to more or less print this thing here by simply doing or using the square function that we saw before. So we do square and we go width would be essentially here in this case 1, because so 1 character width, and we want a height of 2 characters because we are in the middle, and we will see if this actually even makes sense. So 1 times char width. And we want 2 times char height. And we will later see if the proportions are correct or not. So if I actually now render this, we should have our trunk here. Let me move this a little bit more in the middle there. Okay, so that's kind of our trunk. Yeah, might look right, might not. We will see. So we will have that now. So now we want the rest of our tree as always. So what we need to do is we need to kind of draw all of those zigzagging groups. So we usually start with this one, then go to this one, and then go to this one. And this divider here will kind of be implicit because we are always, of course, ending our 3D shapes. So it will in the end be closed down there just after the last zigzag shape. So let's think about those zigzag shapes. Let's go ahead and let's see if we can't maybe draw them somehow. So what we want there is, we call them usually groups. So in this, we can stay in this terminology, however, they are more or less layers, but yeah, let's call them groups. Why not? So what we want here is usually we take some sort of function which we call draw group. So let's do that. Let's call that maybe group profile. Profile, there we go. And usually what we put into our group profile function is we put in there the index, which of those groups is that, because we need to calculate the spacing of this thing, and the full positioning. So where exactly is how many groups do we have in full? And I guess we will need the same information here. So let's put that in there. Let's put in there the I and the length. We can actually do that in a module. We can give it parameters here. So that's exactly what we are going to do. And let's maybe just for to check here, we will just draw the group profile 0 or 3. So just so that we know that there is something working when we have written this. So how would this actually work? We kind of need to somehow move our cursor, I think, our position somewhere here in the middle. So where we actually want to go is in the middle at this top there. So that we can do actually with the translate command. So let's translate to a specific XYZ coordinate, as the Z is always 0 because we are doing this profile in 2D currently. We can just leave it out and it will automatically be made 0. So let's translate to the X position 0, and then we somehow need to calculate where we need to go here. And I guess we should start our calculation at the top position of our trunk, so more or less in this region here. So then that would be kind of easy to calculate, as this would be the length minus I times our char height, wouldn't it? And it would be char height by 2, because all of our groups are 2 chars height. So I guess something like this. So now we should be somewhere here for our 0th group there. And now we can actually, after the translate, open up a block in OpenSCAD, which allows us to essentially use this transform for a group of other commands. So everything that we now do after or within this group here is actually done after this translation of the matrix happens. So now we can draw like with this new translated coordinate system. Everything that we do now is translated there. So what do we actually want to draw? I guess we want to draw a polygon here. And a polygon is essentially only an arbitrary amount of points that we can provide and therefore can draw. So what's the first point that we want to draw? Yeah, I guess the first point here is we want to start at 0, 0, just so that we have this starting point. And I kind of messed up the formatting. I wanted to start there. Okay, so that's our 0, 0 point where we start. That's here. Now we need to move to the next point, which would be down below here. So essentially what we have is we have this 0, 0 point, and then we need to move here. However, that's not 100% true, because kind of first we need to, for every of those layers or groups here, we need to move out. So we are at the starting point here in the middle, and we need to move out to where this thing starts. In the first layer, this starts directly. However, we need to move out there should it start at another position to make this zigzag shape of our tree. So we need to move out. And how much do we need to move out? Yeah, I can actually highlight this here. We need to move out the amount of groups that we are in. So this here is group I equals 0. So we move out 0 times the character. Here in this group, we move out 1 times the character, as you can see in my highlight here. So let's actually do that. Let's move out I times char width. And on the y-axis, we simply stay at the 0 point there, where we actually are currently. So that's actually where we are starting out. However, I did something a little bit wrong, I guess, because I thought we might translate to this position. However, I guess if we do this positioning like that, we are only positioning the thing length minus I. So if we have 3, then we have 3 times the char height. So then we would 6 times essentially, because we are multiplying by 2. So where would we be? We would actually really be, okay, we would be at the top point there. Okay, then this is correct. I was just thinking about if we are at the bottom position of this thing and first need to move up, or if we are really at the top position. But we are at the top position. Okay, so then this is fine. We can do that. We can do it like this. Okay, so now that we have actually moved out here, we need to move down there to the end position of that. Okay, so where is that? That's actually the usual thing. The end position is I plus 1 spaces here. However, we are in our ASCII art, we are using this slash to denote that we are at the end of this thing, and we really need to be at the end of this. So we need to add 1 to that, because we have one of those characters here as well. So this would be essentially the end, would be I plus 1 spaces here plus 1 space there. So we are now moving out and down. We will do that in a second as well. So we will I plus 1 plus plus 1, so essentially plus 2, but just to make clear what we are doing there, times char width. We need that in the x directive, and now we need to move down 2 lines because we need to go there. So essentially, it should be possible for us to do something like minus or let's do minus 1 times, so just to make the thing negative that we are calculating there to move down, 2 times char height. So now we should actually be here at this bottom position in each of those groups. And now we need to move back to the inner to the inner point. So what we now do is we simply copy this line and we move back on the X to the 0 position while staying on the Y position. And if I've not completely messed this up, this should actually kind of create, our first part of this tree. And now we should be able to actually iterate using this technique here. And we should be able to do something like maybe create a module called module tree profiles, and you simply give it the length, and it will then do a simple for loop, because we have for loops in this language as well, and we can do I should be, and this is kind of the syntax here for looping, where we define an I, which then should be our looping variable, and we want it from 0 to the length, and then we could even provide as a third thing here the step, like for example 20 or 25.7 or whatever. However, if we leave that out there, it will simply take 1. So now we will loop this, whatever is in here, and that would be tree profile that we want to call here, and we want to give it an I and a length. And then let's maybe do group, or we should have called this group profiles, of course. So let's now call group profiles here, and let's give it a 3 here, and let's do that. And it tells me that something's wrong here. What does it mean? What's the problem? There should actually be a console somewhere. Where is our console? Wait a second. Error console, window console. Parse error, syntax error in file line 33. So why is this not... Wait, what? Why is this not working? I would have thought this this should work. Isn't that the syntax? Was it a colon? I'm not 100% sure. It was a colon. Okay, so however, now we have other problems. Recursion detected, calling module tree profile. Yes, because we are calling tree profile here. I guess you were already all screaming at your screens while I was doing that. So let's see. Okay, so now we have our tree. However, we did something wrong there, because we started not in the we started kind of at the start here, and not above of the trunk. So we can quickly fix that by simply going ahead and doing a translate before actually calling the group profiles here. So translate, and we translate simply X, we stay at 0. However, the Y, we just move up the amount that our, trunk profile actually has in height. So 2 times char height. So 2 times char height here. And if we move this up now, it should actually I of course need to translate this group profile here. And you can leave out those braces here, for example, if you are just doing it with one command, like you can in certain languages doing with if statements, for example. However, I like it more like that. Okay, so now it is moved up, however, not enough. That's kind of interesting. So why does this not work? Let me quickly check. Was it before? Was it below the 0 line? Yes, it was. Okay. So we are doing something wrong there when we are thinking about our positioning, I guess. So what do we actually do there? First of all, we need length -1 here, because it is always inclusive. That's the first thing. That's why there are 4 of those zigzags and not only 3. So now we have only 3. And then it looks a little bit better. However, that was our problem actually, because we drew a 4th one of those, even though we only needed 3 there, and therefore our trunk was kind of overwritten. But as you can see, though, this looks kind of the 2D version of half of our tree. So we are more or less ready to simply draw something like, I think it is extrude or rotate extrude it is. So we are simply specifying that we want a 360-degree extrude rotate of our tree profile here. And now it should actually create a rotation of this shape around the z-axis here. And now, as you can see, we have a nice, kind of nice Christmas tree here. And yeah, we can make it, you can see all those faceting going on here. We can make this a little bit nicer by specifying something like how many facets we actually want. 300 would be a quite high value. It might take some time to calculate. Okay, we have a quite simple shape, but now you can see that it is really nice and round there. And we might even do something like maybe create some more groups there. Maybe we should put the group definition something like parameters. We could put the amount of groups there as well, like something like 5, for example. And then we can call it like that. We can do group profiles 5 here. And now if we run that, we should have a little bit a bigger tree. Maybe we want the trunk to be a little bit bigger now. I don't know, maybe, yeah, we'll see. 5 kind of, why did I put a 5 in there? I should have put a groups in there so that we actually take our parameter from above. So let's see. 4 maybe. 4 looks kind of nice. Maybe we should add some sort of feet here, some round bigger cylinder at the end so that we can actually make this stand later on when we print that. Let's quickly do that, I guess. So I guess we can do that as part of our tree profile, or we can simply add it in the end here by doing a cylinder, and a cylinder which should be something like we wanted height. Let's maybe do this like 10 high, and let's give it a radius 1, a bottom radius of, I don't know, oof. Yeah, maybe what did we do for our char width? We had a char width of 10. So maybe something like, where are we? Maybe something like 40, and we give it a top radius which is a little bit smaller, like maybe, I don't know, 35 maybe. And then let's see how this actually looks. And now we should have a nice little footer there, a nice little foot of our tree that we can then maybe print, or I hope we can print that. So yeah, now let's maybe do that. Let's get this out into nothing to export, rendering first. Yeah, we need to render. This might take some time, so let's render that. And now we have rendered our shape here. Now we can export it as an STL. So let's maybe output that as hello Xmas STL. I will put that into the repository as well. Let's quickly open up my 3D printing software and put it in there. So now we have imported our design 3D tree into our 3D printing software here. So now we can slice that with a little bit of support that we need there, of course, because of those steep overhangs we created. And now we can actually simply send this to our printer. So once this is done in about an hour and 30, I will make a little bit of video about that and show you the result of the Christmas tree that we kind of programmed here on this final day of our Advent of Languages. And I wish you a very, very happy Christmas, and I hope you had fun that we did this year this Advent of Languages, where we did every day in the 24 days of December the same thing in a different language, and I think this was a proper ending for it. So I hope you enjoyed it. If you haven't seen all of those language videos, the playlist will be linked up there in the top right corner or down low below in the description. Please give this video and other videos of mine, if you like them, a thumbs up. Subscribe if you want to be informed once the next video on this channel is out. I wish you a very, very happy Christmas season and a couple of holidays now, and I wish you a good time, and be good with yourself and your family, and have simply a good time. Merry Christmas, and I see you in the next one. Bye.